Hello everyone, in this tutorial we are going to switch from static mesh to skeletal mesh to animate the flap of the aircraft, and we will add the wheel with the brake for landing the aircraft. We create new folder, name it static mesh, and move this static mesh in this folder. Add folder, skeletal mesh, new folder, texture. And we import the aircraft 3D model. So I will put the link in the description so you can download this 3D model. We can see I rig this aircraft with this skeleton and go to edit to see it, or post this. This is the root, the wheel, and we have this armature, we have the flap L, aileron, elevator, rudder. We can import these textures. Just select and drag in this folder. Go to skeletal mesh and import the skeletal mesh. The Cessna skeleton .fbh. Let's see this. We import skeleton. The skeleton mesh is. We don't need to import the material. We will create it and import. Next, we import these window, wheel, and propeller, which is the static mesh. The same as before, we don't import the material. And we have this. We can remove the collision of this propeller, the wheel, remove collision, and the window. If we want to see the collision, we can turn it on, simple collision. And when we remove it, it will don't have this collision. Next, we can save it. Let's create the material. Name it M standard material. Press 3 and left click. Or you can press 4 and left click. And we can convert this to parameter, name it color. This is the base color. Press 1 and left click. This is metallic. The same, press 1 and left click. This is roughness. Like metallic to metallic, roughness to roughness. Create material. Name it M solid material. And this is texture sample. Like to base color. Convert to parameter. This is base color. And we need to set this default texture. Can click on this reset. And we have this default texture. Next, copy this and rename it to metallic. RGB and roughness. Need to roughness. And here is our solid material. Next, we create emissive material. M emissive. Create texture sample. Convert to parameter. This is base color. Make base color and emissive color. And convert to parameter. This is roughness. We set the roughness to 0.5. And this texture sample, we reset this to default texture. Now from solid material, we can create material instance. Name this to MI body. Let's change the texture. We find the body texture. This is body, base color, body roughness, metallic, and roughness. So this. And Select material, create material instance. Mi higher. And find tile texture, base color, metallic, and roughness. Next is emissive. We create material instance mi1 and change the color. This is for the button of the aircraft. And we can duplicate this. Route D, mi2, change to texture tool, mi3, and mi4. Change to three texture, and mi4, the fourth one. Next, we can duplicate this mi4 and name it mi panel 1 because the panel we need the missile to make it look like the screen. We use this texture and duplicate this panel to panel 2 and change this texture. Next, we create the standard material instance. For the material that have only color, mi black. And we enable this. This is black color. It is correct. Save. We change the roughness to 0.5. And duplicate this material. Name it mi front. The roughness is 0.25. The color also black. Duplicate it. Name it mi interior. And change this color. We have the color BE81 for FFF. Okay. And change the roughness to 0.5. Next is MI interior 2. Change this color to gray. 53, 53 FF. Duplicate this interior material. Name it MI metal. Metallic is 0.7. Roughness 0.5. Duplicate MI metal 2. The metallic is 1. We change the color to lighter gray. 81, 81, 81 FF. Okay. And create material from standard material. 3 instance. MI propeller. This color is 2D, 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 FF. And metallic 0.6. Roughness 0.7. Can duplicate this color material. Name it MIY. Change the color to white. Metallic is 0. Roughness 0.5. And we already create this material that have different color for our aircraft. Next, we create another material. It's for the window, the glass. M window. We change this to translucent to have the translucent surface, and change this volume metric to surface translucent C volume to have this adjustment for metallic and roughness. And we set two sides. Create the color. Base color is black. 0 for roughness. We want it to be smooth. And 0.4 for the opacity. Now we have the glass material for the window. Next, we can apply this material to our skeletal mesh. Go to this skeletal mesh and drag this a little bit. We can see the slot name, and we apply the material with the same name as this slot name. First is MI black. This one, we have this black. Another one. MI interior, this white material, interior tool, body, front, metal tool, this MI1, MI2, 3, and 4. Next is panel tool. And after we apply this material, we can see our aircraft have the correct material. Next, we apply the material to the propeller. Set propeller material, white, and metal. Next is wheel. The tire material, this one, and metal. Window, we set this window material, and we can sell this. Next, we need the physics asset collision. To skeletal mesh, this physics asset. Now we have the spear for the collision. It is different shape from this aircraft. So we delete it. And we enable show all bone, show primitive, and show constraint. At the root, we need to add the primitive collision. Let's click this add. And we add the box collision. Name it collision 01. And to see the geometry, we can go to detail and these primitives. We have this box. We have collision 01. We going to adjust this location and the extent of this box. We can use the scale of this to adjust it, but I want to be much more accurate to my project, so let's type in this value. The location minus 110 minus 143. Rotation is 0. X extent is 106. 300. Y extent in Z is 106. This is the first collision box. We need to add more collision. Add box. Name it collision 02. And change this minus 130.9, 381, 100.6. X extent is 3. Y 102. 347. And we get this box collision. Next, add box. Name it collision 3. The center minus 204.6. 423. And we change the rotation minus 90. 3.88. 102. Z is 144.5. And this is the rudder collision. Add box collision. Name it collision 4. We need the collision on this wing. Minus 208. Minus 52. This X extent is 10. 115. 1082. And we need the capsule collision for this tail. Add capsule. Name it collision 5. And scroll down. We have this capsule, one index. The center is minus 129. 560. Rotation 90. We change the radius to 25. The length 247. And we save this. If you change this collision shape, the center of mass of the skeletal mesh will be different. So we need to make sure that our aircraft have the same shape, so we have the same effect on the physics. Next, we will generate Visual Studio project file. Open aircraft.sln. We need to change the static mesh component to use skeletal mesh component. In this aircraft pound.h. Go to aircraft pound.cpp and we create the default sub object with use skeletal mesh component. Save it. Go to aircraft physics component.h and we can delete this. Go to aircraft physics component.cpp. This physics component, we change it to get the skeletal mesh component. New skeletal mesh component. Mesh equal get owner. Find component by class. Skeletal mesh component. Use skeletal mesh component. If this mesh is valid, we set to physics component equal this mesh. And this one, if the surface is not valid, we continue instead of return. Save all of this and can close. Delete binary intermediate cell, and we generate Visual Studio project file again. And open it and run it. And we run this. We go to BP airplane. We don't see the static mesh because we change it to skeletal mesh. This aircraft mesh. So we need to switch to this skeletal mesh. And we can create the animation blueprint. This Cessna skeleton. Create ABP aircraft. And connect to this anim class. The center of mass, we can change it to 0, this X, Y to X, and the collision to block all, and collision enable query and physics. Save this, and we play test. When we play, we didn't see the blueprint of the aircraft spawn in the world because it have the overlap of the physics. Let's find player start and move it up a little bit. Change the Z to 1000. And when we play, we can see this aircraft is spawned. Next, we change the mass of the aircraft. Go to physics asset and enable this mass to 850. And we can change this linear damping to 0. And the aircraft thrust, aircraft physics, this thrust to 35. This is 350,000. The thrust. Play test this and press space to start. So our aircraft, we can fly it normally. Next, we want to, after we spawn, we want it to move to the floor location. So in begin play, this sequence, get actor location, line trace by channel, add it with Z 1000, Z minus 1000, and this is the add. We add the branch. If it hit, we move it to the hit location. Set actor location to the location. Play this. Let's check this collision. We can change it to custom, and this collision query and physics is correct. And we change this to teleport. In the ball teleport, move it a little bit down, about 900. And we can see our aircraft is spawned on the ground because we change the location with the line trace. Next, we want the animation of the wing. To content FBP aircraft, add variable. This is float. Name it aileron L angle. Duplicate aileron O angle. Flap angle. Elevator angle. Rudder angle. Next, we modify the bone. Mesh space. Rect pose. Modify bone. Transform. We drag this. And we change this. We don't need this transform location. Remove this pin. And the scale. We remove this. And we need to change the rotation. The rotation space is bone space. And add to existing. Bone modify is bone aileron L. and we compile, get aileron L angle, make rotator, and this is the pitch. Copy this and make rotator, aileron or angle. Change this bone to aileron or. Copy. Flap L and flap O. Make rotator. This is flap angle, pitch, and another one. We multiply this flap angle by -1. If we don't multiply, the left and the right flap will have opposite rotation. Modify bone. This is elevator L. And elevator O. Elevator O. Next one is rudder. And make rotator next to this. This is elevator angle, the pitch. Elevator angle multiply by -1. And this rudder header rudder angle pitch. Like this. And output post. Component to local. We save this. Next, go to BP airplane, and in begin play, we get this aircraft mesh, get Anim instant, has to ABP aircraft. This is animation blueprint, and promote to variable, name it ABP aircraft. And in event tick, we set the value to modify the bone. Move this a little bit. We add a sequence. ABP aircraft is valid. And this one, we have the sequence. We get role input. multiply by the angle that we want to rotate. The max angle is 25 and divide it by 0.2. We divide by 0.2 because our roll input we multiply by 0.2. And get ABP aircraft, set aileron L angle. Like this. And the same for aileron O angle. Set and get flap input. Multiply by 30 the max angle and divide by 0.3 because here we multiply by 0.3, so we divide it by 0.3 and get this ABP aircraft set flap angle. Next is get pitch input. Multiply by 30 divide by 0.3 get ABP aircraft. We set elevator angle like this, and we need to set the rudder with your input. This is 20 degree divided by 0.5 and ABP aircraft set rudder angle. Compile. We play test. So now our flap have the animation. We can see this animation. All is working, all the flap. Next we change the propeller because we still use the old propeller. Change the name. Cessna propeller, and this is the new propeller. And we change the location. This X is 310. Check the collision. We can change to no collision. And the mass, we set it to 0. And save this out. Next, we need to improve this animation of the propeller. because now our rotation is constant. It's immediately set the full speed when we set the throttle input to true, and we stop immediately when the throttle input is false. We want to do the interpolation of this value. Add variable. This is target roll angle float. When it's true, we set to 24. When it false, we set to 0. And we add another variable is current roll angle. Set this current roll angle. Get current roll angle f interp 2. We get world data time, world data second, and we need to change the interp speed 0.25. So we loop between this roll angle and target roll angle. Next, we add this rotation with this current roll angle. And compile and save. Let's see, and we start. The propeller will move, rotate slowly, and then it gets faster. And when we stop, it slows down the propeller a little bit, not stop immediately. Next, we can duplicate this static mesh of the propeller. Duplicate, name it Cessna window, and change to this window. Change this location to 0. Make sure we don't have the collision and the mass is 0. Next, we need to delete this gear. That is the sphere collision. Delete it. And we remove the slippery material from this floor plane. Remove this physics material override. When we play, we don't have the wheel collision, so we need to create the wheel collision in the physics asset. Enable show all bone. Enable this primitive and constraint. First, we create the front wheel. Right click, create body constraint, and with capsule. Just this capsule, the mass, we change it to 20. Is 0, and angular damping is 10. So it's have stop the wheel for the angular damping. And we change the primitive of the capsule. We change the rotation. This to 98 and Y This is row. The radius, I measure it. It is 17.75. Size of the wheel. And the length, and adjust it. 17.75. And the constraint. Now we can rotate on any direction. So we need to lock the swing. And swing 1, swing 2 is free, and twist motion, we lock it. So it only rotate on this swing 2. Do the same for wheel left and wheel right. Create body with capsule. This is the mass 20. Linear damping 0. Angular damping is 10. And change the capsule. This 0. And rotation 90. 17.75. Length is 17.75. And change this constraint. This is lock and lock. This wheel all. Create body with capsule. Mass is 20. Linear damping is 0. Angular is 10. 90 and 0. Radius 17.75. The length is 17.75. And we change this constraint. This linear limit, we need to lock all of it, and angular limit. Swing 1, lock, and twist motion, we lock. Next, we need to create the wheel physics. So, go to physics, physical material, and select this, create PM wheel. We change some setting in this. The friction is 0.35. If you want higher friction, you can increase it. And override friction combine, we multiply. The risk distribution is for the bounciness. We don't want the wheel to be bouncy, so set it to 0. Go to the physics, this physics asset, select on the capsule of the wheel, and apply the physics material. Set here. The same with this physics material, and this one is physics material. PM wheel. Save it. We can play test now. And we play. The wheel is moving. It's working. Let's add the static mesh for the wheel. So when we can visualize the wheel. Duplicate this window. Name it wheel app. The snare. This is the wheel. And we snap it. to bone wheel F and duplicate this wheel L, bone wheel L, and bone. This is wheel O. Snap to bone wheel O. And we check the collision, make sure it is no collision. So when we snap to the bone, when the bone rotates, this static mesh will rotate with the bone. We can enable the collision to see the collision. So this one, the collision, play, and we press F8 to get out of it, and we can see this wheel rotate of the collision. Next, we need to create the brake. So we create the input first. Duplicate this IA throttle because it is Boolean. IA brake. We have digital bool. And close this. And go to IMC default mapping, add IA brake. Change this to B. When we press B, we set the brake. Save it. Go to BP airplane. IA brake. This trigger do one. And complete. We reset this do one. Flip flop. Get aircraft mesh. Get constraint by name. We get the constraint is bone wheel O. Make sure it is the same name as the constraint. Check the constraint. Here, this name. Wheel O, wheel F, wheel L. And we set angular limit. This when we brake, we lock all of the motion. The wheel. Wheel L. We lock all of the motion the same. And copy it. And wheel O. We have wheel O, wheel L, and wheel F. Then copy this. When we stop brake, we set this swing to motion type to 3. The same with this. Swing to motion type 3 and swing to motion type 3. And we want to have the widget to visualize the brake. Go to WB widget and we add some instruction to this. So C Ctrl V. We can change this to 0. It is correct. This one is 0 for the padding bottom. X is break toggle B. Break toggle B. Break toggle B. And this border, we extend it a little bit the size. Y is 252. And this we need to duplicate and change this to break. And we need to remember this name text block 7 is variable. In event text, we copy this change this to text block 7 and we delete this, add variable break boolean, we switch, select the string. If it is true, name on. If it is false, off. And append this is break. To text. And save this. VP airplane. When we create the widget, we can promote this to variable. This is the widget. And when we set the break, we can set the widget boolean get widget set break is true and this one break is false. File and save. We can change the adjust this spring arm a little bit. This target arm length is 1300 and offset Z is 400. And then we compile and save. Let's play. And this when the brake is off, the wheel will rotate. Let's fly this plane a little bit. And then we stop. Press space to stop the throttle. We're going to land this plane. Press B to brake and we can see the brake is on. And the plane will stop faster than we didn't set the brake. If we want the brake to stop faster than this, you can set the friction to more friction. And this is the end of our tutorial. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.